Today, what I will explain you is we're talking about the for loop impedance. So this is the supply, this is the equipment. So from the supply to the equipment, this is we call the external resistance, and inside the supply, the impedance is internal impedance. So there are two kinds of the impedance: external impedance and the internal impedance. So the impedance value for the calculators are for loop impedance. So the for loop impedance total F for loop. This means that when the electrical fault happens, the current coming through the both are external internal element and go to the ground. So this is why that we calculate the total F for loop impedance is ZS. ZS can be equal to this U0 by IA. In this case, U0 is a nominal phase voltage. IA is a current causing the automatic operation of the protective devices. Therefore, this IA value can be determined. It's depending on the type of the circuit breaker. Type B circuit breaker, IA is a 4-type rated current of the circuit breaker. Type C circuit breaker, IA equal to 7.5 type rated current of the circuit breaker. Type D circuit breaker, IA equal to 12.5 type rated circuit of the current circuit breaker. So this is the ways how we calculate the IA. So if you know the IA, you can calculate the for loop impedance. So therefore, if we calculate this, we also need to calculate the maximum demand. The maximum demand is depending on the cable selection. So in this case, our cable selection depends on the arrangement of the circuit, length of the circuit, and the socket outlet circuit. So they are the depending on the which equipment are the included in the circuit, how to arrange the circuit, and also the length of the circuits. So depending on those circuit arrangement, we have to select the cable. In the mid-type cable selection, also depending on the for loop impedance, also the for loop protection. So that's why those are things have to be concerned to determine the wiring circuit diagram design. So based on those facts, we design a wiring circuit diagram. Then if you get this wiring circuit diagram, then depending on the wiring circuit diagram, we can draw the single line diagram, and then we can do the connection diagram. So this is a typical circuit diagram. This is line 1, line 2, line 3, and a neutral wire. So the line 1 is connected to the active base switch and connected to the equipment and connected to neutral. And this is I connected to ground. So neutral us are connected by the NBM, the main active neutral system. Now we have to connect it. And cable impedance we have to calculate. When you use a cable impedance, depending on the cable impedance, we have to select the AS3008. So table 34 to 39, we have to follow the AS3008, table 34 to 39, and we can calculate the cable impedance. So the best equation is R equal to RCL by 1000. R is the resistance of the cable ohm. RC is the table value. So this impedance value you can get from the table 34 to 39. Depending on the type of the cable, you can determine the cable impedance. And also this is the weight of the table value ohm per kilometer as the length of the cable. Then you calculate this RC equal to divided by RC equal to RC. R equal to RC divided by 1000, then we can calculate the cable impedance. So this is the AS3000. We show the tables are 34 to 39. So table 34 to 39 we go through. So table 34 is a single core cable, copper cable, aluminum cable, depending on the conductor cross-section area, we calculate the table impedance 45 to 90 degrees centigrade. And also the table 35, this is multi-core cable, copper conductor, aluminum conductor, we can calculate the table impedance. And table 36 is a multi-core cable, sheets are multi-core with the shaped conductors. So this is for the cable type, and depending on the copper and aluminum, depending on the conductor size, we calculate the cable impedance, ranging from the 45 degrees centigrade to 90 degrees centigrade. Table 37 also, flexible cross and a flexible cable with copper conductor. We calculate the cable impedance. And table 38 is MIMS cable, metallic sheet cable, mineral insulated metallic sheet cable. So we calculate the temperature, conductor temperature, and the cross-sectional area. We calculate the cable impedance. And also the 39 single core area bell or the insulated conductor, depending on the copper and aluminum as a material, we calculate the cable impedance. So this is the ways of how we calculate the cable impedance. Cable impedance. So that we have to calculate this characteristic AC resistance. We need to calculate characteristic AC resistance of the single core conductor. In the 45 meter less of the 10 millimeter square 4 core and the others cable. So 4C plus E V90 copper conductor. So in this case, there will be the table 34 single core, table 35 multi-core circular shape, table 36 multi-core and the shaped conductor, table 37 flexible, table 38 is MIMS, table 39 is single core area bare conductor. So the across there's a problem given the is the 4 core and the others, so that this is the multi-core. So we have to select that table 35. So table 35, 10 millimeter square and 90 degrees centigrade. So table 35 we select here, 10 millimeter square and 90 degrees centigrade. Table 35, go back here. 10 millimeter square and 90 degrees centigrade. Here you got 2.33. Substitute 2.33. RC equal 2.33. Then R equal to RC by 1000. RC 2.33. Then is given the 45 meter and divided by 1000. You got 0.1050. And then this one we also we calculate. This is for the cable impedance. So this is the way we calculate the external resistance depending on the cable. And also the internal outflow impedance can be calculated. ZIND is equal to 0.8 U0 divided by IE. So that's equation. U0 is nominal voltage, IE the circuit breaker operating current, and this Z internal impedance you can calculate by this way. So this problem we find out here. Outflow impedance. We need to calculate the maximum permissible outflow impedance, ZIND of the current supplying the hot water service type C. Service type C is a 20 ampere magnetic circuit breaker in 230/400 volts installation. If this circuit is wired in the 3.75 millimeter square 2 core plus arc V90 orange circular cable and the length of the cable is 16 meter. We need to determine the impedance of the cable between the active and the protected earthing conductors, and does this circuit comply with the AS3000 or not? Calculate the voltage drop of this section of the cable. So those they have to be calculated. So firstly we have to calculate the ZIND 0.8 U0 by IE. In this case, U0 is a phase voltage 230 volt, and also the IE is this is a type C circuit breaker 7.5 times fault current. In this case, 20 ampere. 20 ampere is an MCV current. This one multiplies 7.5 because of the type C. So the I equal to type C circuit breaker current multiplies 7.5. This is the rule. So by substituting the formula, we got a 1/2270. Cable resistance must be less than the ZIND to comply with the AS3000. And unleakage circuit breaker we work. This is the rule. When you calculate the deck cable resistance, it must be less than the calculated value ZIND. So if the cable resistance is less than this value, and circuit breaker will be working. So this is the way so firstly we calculate the ZIND, so then we got the 1/2270. Then we also need to calculate the cable resistance. Cable resistance is a multi-core cable, 2 core plus arc. So in this case, a multi-core cable, we have to use a table 35. Table 35, and also the cross-sectional area is 2.5 millimeter square, temperature is 90 degrees centigrade. So this is the way we have to know about. The temperature is V90, 2.5 millimeter square, 2 core plus E. So this is the 2 core, so multi-core cable, 2.5 millimeter square is a cross-sectional area, V90 is a temperature 90 degrees centigrade. So that we shall select the table 35. So 90 degrees centigrade, 2.5 millimeter square. So this is table 35. copper conductor 90 is 2.5 millimeter square. Here you got the 9.45. So 9.45 you get it. We substitute 9.45. And length of the cable. Length is a 16 meter. Substitute a 16 meter and divide by 1000. So you got the 1.134. So the internal resistance is 1.227. External cable resistance is a 1.134. Therefore, this resistance value is less than the internal impedance. So it's comply with the ASR 3000. So if also comply with the ASR 3000 and unleakage circuit breaker will be working. If we calculate the cable resistance value is greater than the ZIND, it will not comply with the ASR 3000. So unleakage circuit breaker will not be working. So this is the importance of you select the appropriate internal impedance and the cable resistance. Whether the circuit breaker will be working or not at the time of the unleakage condition. So therefore, that we need to comply with cable resistance must be less than ZIND so that it will comply with the ASR 3000 and unleakage circuit breaker will be working when the unleakage fault happens. So this depends on the different other problem we have to calculate. So multi-go cable, another thing are 2-go cable. Those things we have to calculate. Those programs are also given. The next one is a maximum length of the conductor. How long the cable you should draw to comply with the ASR 3000 rule. So this is the maximum length of the conductor. Any circuit, how long you should draw the cable. So this is the maximum length. So L maximum depending on this equation, 0.8 multiplied U0 SPH SPE divided by IA rho SPH plus SPE. L maximum is a maximum roulette in the meter. U0 is a nominal phase voltage. Rho is a resistivity. In this case, our copper resistivity 22.5 into 10 power minus 3 ohm millimeter square by meter. IA is a current causing the instantaneous operation of the circuit breaker. SPA is a cross-sectional area of active conductor. SPA is a cross-sectional area of the protected earthen conductor. So that those are the given the information whether how long you can draw the maximum length of the conductor. So based on this information, we calculate this problem. Calculate the maximum rule length. This is a cross-sectional area 4 millimeter square. 2-go plus earth conductor V90. So the circuit is supplying the good dogs are protected by the C25 ampere clip are MCB into the discharge of 400 volts installation. In this case, U0 is 234, SBA is 4 millimeter square, and IA is 25 millimeter square. This is the type MCB, so 7.5 die to 25 ampere. And then we have to calculate the SPE. So in this case, we have to find out the what should be the phase conductor. SBH and SBE. SBA is crossing the area of the active conductor. SBE is a crossing the area of the earthen conductor. So these problems are to calculate the maximum. We already know that this equation we have to substitute. U0 we know it. SBA we know it, but SBE we haven't know it. IA value, we already calculated the IA value. This is 7.5925. And rho also we know that copper, this is 25. Copper is this value is given as 22.5 into 10 power minus 3 ohm millimeter square meter. So those things are you calculate. So we have to find out the SPE. SPE is protected as a conductor. So in this case, the conductor side, depending on the active conductor side, we refer the table 5/1. So we have to find out the table 5/1 of the ASR 3000. So we open the ASR 3000, we find the table 5/1. So go back and find the table 5/1. So this is table 5 by 1. So table 5 by 1, this is the cross-sectional area of actin. This is cross-sectional area of the copper actin gonada. This is aluminum actin gonada. So the cross-sectional area is actin gonada given the 4 millimeter square. Because of 4 millimeter square, we find out the 4 here. So this is the 2.5 millimeter square. Gonada size 2.5 millimeter square. So therefore, we substitute in this formula 2.5 in the place of the SPE. In the place of the SPH is a 4. Then we calculate the 67 meter. So the maximum length of the gonada should be the 67 meter. You should not draw them more than 67 meter. If you did, it will not. It will also overheating the cable. Also, it will not protect it against a gonada. Affordably will not be working. So this is for the point of the supply. Consumer main, here main switch board, here is sun main, 400 ampere, and distribution board and the load. So this is the arrangement of the your circuit. In this case, this is a 100 millimeter square. So this is given the information. So this cross-sectional area of the cable is 100 millimeter square. So that will be the copper conductor is given, line to phase, line, active, and then phase and the arc conductor included. And they are arranged with the 3.5, and the IZ value is a 403 ampere. And this is a maximum demand 150 ampere. Length is a 300 meter. And also the fault current rating of the circuit breaker is an 8-time circuit breaker rating. So the information. So in this case, we have to follow this thing. IB is less than IN less than the IZ. So maximum demand current is an IB 150 ampere. IN is a protected by rating. Protected by rating given a 400 ampere. IN 400 ampere. And the IZ value will have to be calculated. IZ is a 4 loops are 4 current can be calculated. So in this case, the 4 loop current also the 403 ampere is given. So in this case, it complies with the AS3000 because the informations are the IZ 403 ampere when the fault current happen, and also the IN is a protected by rating, and IB is a maximum demand current. So it's comply with the AS3000. And also we also need to calculate the voltage drop. Voltage drop is calculated at VCLI by 1000. It does not say that the number of go, that's so that we have to assume that single go cable. Cable 40 had to be utilized. So the cross-sectional area of cable 100 millimeter square, temperature 90 degrees centigrade. So therefore, cable 40 of the AS3008 have to be calculated, utilized. So this is that we find out the cable 40. Cable 40 of the AS3008. So the 150 millimeter square. Then we have here we see about the temperature. Temperature 90 degrees centigrade, 100 millimeter square, 0.316. How to get here? 150 millimeter square temperature 90, so that this is 0.316. So this 0.316 is this one is our VC value. VC 0.316. Length of the cable is we calculate the length of the cable is 300 meter, and also the current maximum demand current 150 substitute, and then you got the 40 by 22 volt we got. So in this case, this 40 by 22 volt is less than 5%. 5% of the supply voltage 400 volt, 5 is 20 volt. So the 5% of supply voltage is 20 volt. We calculate the voltage drop is 40 by 22 volt. So this is less than 5%. So this is acceptable. Then we also have to calculate the maximum length of the design, this system. So we substitute here ZIND equal to U0 by IA. 0.8 U0 by IA. So 0.8 U0 is a 230. IA is a maximum current we calculate is a IA is a 400 ampere. This is a 400 you got it for current. So this IA is a 400 ampere. 8 multiply circular rating. The circular rating we got. So 8 multiply circular rating, you got the here is 400. So this 400 shall substitute here. So 8 into 400, so you got the 0.05750. So you need to compare with the K-value system. So in this case, this is a ZINT is a 0.0575. So we have to find out the K-value system. Whether it comply with the circuit breaker AR3000 or not, whether upper circuit is a protect or not. So ZINT 0.8 U0 by IA, that formula. So 0.8 multiplied 230, 8 into IA value is a circuit breaker rating is a IA value. So this will be the substitute the 400 volt ampere. The current wiring rating. So this is the 400. IM value 400. So IM value is 400 here. So we calculated IM 400 ampere. This is a protected device rating because here given 400 ampere is given. So this 400 ampere we substitute here. Here this 400 ampere we substitute and 8 times. So because of the magnetic circuit breaker, so 8 times the 400. So this is the IA value. U0 is a 230 volt. So 0.05750. This is a ZINT. This ZINT need to be compared with the K-value system. So K-value system is called the active wire and the out wire. Because of that, from the active wire going through, current going through the active wire and going back into the out wire. So therefore, the total K-value system is active wire and out wire. Current will be flowing through. Current flowing through the active wire, then go to the passing through the equipment and go back to the earth by passing through the out wire. This is why we have to calculate the active wire and the out wire. So the active wire side is the impedance need to be calculated. Out wire impedance need to be calculated. Active wire impedance is a 150 millimeter square cross sectional area given. This is single core. Single core, therefore we utilize the table 34, 90 degrees centigrade and 150 millimeter square. So we find out the tables are 34. So because single core is a table 34. So 150 millimeter square and 90 degrees centigrade. So 0.16. So we got 0.16. So the RBA 0.16 multiplied that is a 300 and divided by 1000 you got a 0.048. And also out wire side. Out wire is not given. So therefore we have to find out the table 5 by 1. Because the active wire 150 millimeter square, out wire side need to be calculated. So we refer the AR3000 table 5 by 1. 150 millimeter square active wire, out wire side 50 millimeter square. So out wire side we got it from here 50 millimeter square. Then based on the 50 millimeter square, we refer the 34 and we find out the resistance. So that we find out the given resistance. Given 34, 50 millimeter square. So 0.494. So this 0.494 we substitute here. So this 0.494 multiply 300. That's all the given RC by 1000. So RC 0.494 is a 300 divided by 1000. You got that 0.1842. Then we add together to the resistance RBA by RBA. So 0.048 plus 0.148, you got the 0.1962. So in this case, RC must be R must be less than RINT. RINT is a 0.575, R is a 0.1962. So this R is a not less than RINT is even greater. Therefore, it does not comply. It does not comply. It will not circuit breaker and leakage circuit breaker will not be working. Therefore, we have to change the internal resistance because of in this case, we have to find out the internal resistance, how to make the compliance. How to make the compliance? In this case, active wire side is depending on the maximum demand current. Because of the active wire, we already selected based on the maximum demand. We can only increase our wire side. Because of the because there are two resistors. Active wire, RPH, and other resistors are RPE. RPH and active wire side is cannot change. The only possible thing is we have to change the wire side. Our side is originally we select the 50 millimeter square, so it does not comply. So that we have to increase the wire side. So another side is increased. So the this tables are 50 millimeter square original wire. Now we 70 next one. In this case, 0.342. So that 0.342 substitute formula, and then we calculate again the resistance. So in this case, 0.342 we substitute here. So the 0.1052. Then we add it again 0.1506. So in this case, ZINT, we got it here. So this is the resistance. So therefore, we increase as a resistance as well. So in this case, ZINT is to be calculated. In this case, another thing is that we have to reduce. Circuit breaker current has to be reduced. So circuit breaker is we use as originally 400 ampere circuit breaker. So we reduce it 150 because of the after 400 there will be 150. So this 150 you calculate it ZINT 0.153. ZINT 153 we got, and here is RPH RPE. We also increase the circuit breaker side of the your given. So this is 106. So therefore the ZINT is greater than the RT. So that will be acceptable. Therefore the change has to do is instead of using the 400 ampere circuit breaker, we change to the 150 ampere circuit breaker. I think that is increased to the 70 millimeter square. Because you cannot change the active wire side because active wire is running through all the cable, all the systems, so it's impossible to change the active wire because all the drawing. Only thing you can do is you change the circuit breaker. Circuit breaker is easy to change because of the panel. You can take out the original circuit breaker, put another one. Output data side can be changed because I draws are separately. Therefore, the originals are 400 ampere circuit breaker and our side 50 millimeter square does not comply because aggregate circuit breaker will not working. Therefore, instead of using the 400 ampere circuit breaker, we change to the 150 ampere. Based on the 150 ampere circuit breaker, we can calculate the new ZINT. This is the 0.153. And also that we increase the adding data side. Originally is a 50 millimeter square. We increase to the 70. So therefore, we calculate again the resistance, and then based on the load resistance, those changes are total ZRT is equal to the 0.1106. So this is less than the ZINT 0.153. Therefore, it complies and the circuit breaker will be working. So this is the ways we can do this. Today's lesson is how to maximum follow impedance, unfollow impedance, and how to change your circuit component to comply with the AS3000, whether your unleakage circuit breaker will be working or not at the time of the unleakage circuit. So therefore, today is we calculate the maximum length of the cable, also the unfollow, and also the compliance. Whether your unleakage circuit breaker will be work or not, those things I explain you in this lecture. Okay, the next one will be the electrical trade practice 3. electrical engineer trade practice or trade 2. So that one is a electrical engineer practice for the Bachelor Applied Engineering. And now I'm talking about the trade 2 subject, electrical trade practice 3. So we start from the last week we already talked about the heating control system. Now we continue the next one. Twist heating appliance. So the electrical heating is depending on the nature of the heat and also behavior of the heat. So energy conversion is producing the heat. So electrical heating is you need to keeping one in the way winter condition, winter time. But disadvantage is heating cable appliance during the use because of the electrical current is so much electrical current flowing through, so that it can heat the cable and appliance when you are using. Heat in the body, when the over temperature happens or heat in the body happens, in this case, it can cause a personal injury. In the meantime, equipment damage can happen. Over temperature can cause a personal injury. Heat in the body also causing a personal injury. So the heat is a form of the energy. Chemical, electrical energy can be converted to the thermal energy, chemical energy, and mechanical energy. So the heat energy increase, body temperature will be increasing. So we use a Kelvin scale. Kelvin degree scale is 273 plus C. So absolute zero is a minus 273 degrees centigrade. So heat can be calculated MC into delta T is the equation. Here is a heat energy joule, and is a mass of the material kilogram, C is 4180 joule per kilogram degree centigrade, or a 4.2 kilojoule kilogram degree Kelvin. Delta T is the change of the temperature. So those things we calculated. So this is what H equal to MC delta T. The problem is a 1200 watt jug takes 3 minutes to boil the water. How much energy is used? So the energy E can be calculated power multiplied time. So the kVA is a kilowatt into hour. So this is the way we calculate the energy. So that in this case, the 1200 into the 3 minutes, so 3 into 60, so you got the 216 kilojoule, 216,000 or 216 kilojoule. So the next one is how long will it take to the 1,500 watt charge to boil the water? Is 5,000 joules of the energy utilized. In this case, E equal to P multiplied T. T is E by P, so the 5,000 by 1,500, you got the 3.33 seconds. 1 kilowatt hour is equivalent to the 3.6 megajoule. 1 kilowatt kVA is given the 3.6 megajoule. So 1 kVA is a kilowatt into hour. Heat moves from the higher temperature to the lower temperature. This is the nature of the heat. So the next problem is that a 244 radiator takes the 2,500 watt for the 2 hours. So we have to calculate the amount of electrical energy used in a kVA. So the E equal to P multiplied T. So power is 2,500 by 1,000. You got the kilowatt multiplied 2 hours. So you got the 5 kVA. So this problem that a 240 volts range draws a current 32 ampere for 60 minutes. We need to calculate the amount of the electrical energy used in kVA. So the kVA is kilowatts into hour. kVA is a watt per 1,000. Hour is a minute per 60. So in this case, the VI power is a voltage multiplied current. So the voltage is a 240 volt and current 32 divided by 1,000. We got the kVA, and also the 1 hour is 60. So we do 7.6 an hour kVA. This is the way we calculate it. So the heat transfer is when the heat is cooler elements are touching, heat will transfer from the hotter to cooler. This is a solid, so this is the conduction method. And convection method is for the liquid. Heat is when you heat, the particles will move up, and then they will also move down. So this is the way circulating. So this is the molecule in liquid will be circulating like this. So this is the heat transfer in the liquid. This is the convection. And also the radiation method from the sun to earth. Sun and earth are not in touch because heat will be radiated through. So this is the in the radiator in the form of the electromagnetic heat waves are passing through from the coming from the sun and reaching the earth. So this is where the heat will be transferred like this. So three methods of heat transfer are the conduction, convection, and the radiation. So the heat conductions are depending on the temperature difference, area, length, and the specific heat capacity. The specific heat capacity can be calculated. The quantity of the heat energy required to raise the temperature of the 1 kilogram of the material to the 1 degree Kelvin. So this is the specific heat capacities definition. The unit of the specific heat capacity is a kilojoule per kilogram Kelvin. Temperature in the system depends on the mass, specific heat capacity, and the quantity of the heat energy. So the W equal to MC TH minus TC. So this equation we have to calculate the formula. Maximum heated efficiency. Heated efficiency is a percentage N equal to watt output divided by watt input into 100. So percentage efficiency, watt output energy joule, watt input energy joule. W equal to MC TH minus TC. W is the quantity of heat, joule, and the TH minus TC change in the temperature, degree Kelvin or degree centigrade, M is a mass. C is the specific heat capacity, joule kilogram per Kelvin. We have to determine the heat required to heat the 1 liter of the water, 1 kilogram from the 20 degrees centigrade to boiling point 100 degrees centigrade. We have to calculate. So in this case, we find out the equation. So the W equal to MCTH minus TC, so 1 kilogram into 4 by 2, TH at 100, TC at 20, so you got the 4 by 2, so that's where we got the joule. And also a block of the copper with the mass of the 2 kilogram has a 10 kilojoule of the heat added in the initial temperature of the block was at 20 degrees centigrade, determine the final temperature. So the C copper is 390. So the W equal to MC delta the equation. So W is the 10 to the power 3, 2 kilogram, C is the 390, TH minus TC. So in this is TC 20. So that we transport this equation. So that we calculate it. So there we got 32.8 degrees centigrade. And the next one is determine the heat required to heat the 0.75 liter of the water in an aluminum saucepan with the mass of the 0.25 kilogram from the 20 degrees centigrade to boiling point 100 degrees centigrade. So in this case, we have to assume the heat loss to be the 0. In this case, saucepan specific heat capacity of 400, 900. So that in this case, W equal to 0.25 into 900 into 100 minus 20, you got the 18 kilojoules. So this is the way we calculate it. The next one is a percentage heat efficiency is a W out by W in. So that equates the problem is a 240 volts or 240 volt 6 ampere just raise the temperature of the 500 gram of the water from the 20 degrees centigrade to 70 degrees centigrade in the 5 minutes. We need to calculate the efficiency of the gas. So in this case, W is the MC delta D. Mass is the 500 1000. So gram is the change to the kilogram. C the 4 by 2. Delta T is 70 minus 20 is equal to 100 kilojoule. What input is a VIT? Voltage, current, and the time. Voltage 240 volt, current 6. Time is a 5 minutes of 5 into 60. You got the 432 kilojoules. Therefore, the W out divided by W in, so 100 divided by 432 into 100, you got a 21%. And the next one is a 250 grams 60 watt copper soda in, raise the temperature from the 25 degrees centigrade to the 125 degrees centigrade in the 4 by 5 minutes. We need to calculate the efficiency of the iron. So in this copper, so the heat capacity 390, so the WI is the MC delta T. So my is at 250 grams, so 250 grams 1000, and C is at 390, and 125 minus 25, so you got that 49750 joule. The W is a VIT, voltage multiplied current by time, or the power multiplied by time. So in this case, the power is given the 60 watts, so the 60 substitute. Time is a 4 by 5 minutes, 4 by 5 into 60, you got there 16200 joule. So the W out by W in, so 9750 divided by 16200 into 100, you got a 60%. The next problem is electric jet has an efficiency of 84%, and the raise the temperature of the 2000 milliliter of the water from 50 degrees centigrade to 90 degrees centigrade in the 6 minutes or 40 seconds. We have to calculate the power input. So therefore the W out equal to MC delta T. So mass is equal to the 2000 milliliter, 2000 by 1000, and C is at 4 by 2, and then for 90 minus 15, so therefore 600 kilojoule we calculated. Then we also find out the efficiency 84%. So efficiency 84%. So the output power is 600 divided by 0.84, so 714.2 kilojoule we got. Then the you go to P multiplied by T, so 7114, and power is unknown. Time is 60 minutes or 40 seconds, the same multiplied by 60 plus 40. Then you got the 400, so we calculate the power equal to 1.785 kilowatt. We calculated. The next problem is consider the 2.5 millimeter square single conductor which has a resistance of 9 ohm. The length is 1 per kilometer at the 75 degree centigrade. The current carrying capacity in AS and S 3000 in the cable is given, so this is about the 25 ampere, and C5 is 25 ampere. So in this case, we have to calculate the produced energy. So in this case, W equal to I square RT. So I current, R resistance, T is time. So the current is 25, substitute, resistance is 9, and the time is 1 second. You got the 95625. So we calculate that. So this is the one we calculate. The same cable from the above problem is installed in a partially surrounded thermal insulation, cannot carry the same current. So the current carried from the cable C5 only the 20 ampere. We have to calculate the heat energy produced. So therefore, in this case, we calculate for the heat energy. W equal to I square RT is, so you substitute I square into R into T. So the I is 20, R 9, and the T is 1. Second, you got the 36000 we calculated. And now it's a heat and the cable, electric cable. The amount of heat energy developed in the cable will depend on the conductor resistance and the current carries by the cable for a period of time. So heat is continuously produced whenever the cables find the cables carries a current and the mass escape of the cable temperature will rise. So in this case, excessive temperature will cause an agent in the light of the insulation, and it may even cause the melting. So that most of the PVC cables are designed to operate normally at the normal temperature. So this is the ways how the things are heat and temperature cables. So we have to only allow the rated current in the cable. When the temperature is too high, current is higher. In this case, it will damage the cable insulation. Therefore, we also have to depend on the nominal temperature. We allow the cable to operate at the nominal temperature. So in this case, ambient temperature we usually base 40 degrees centigrade. And next you can talking about the reverse circuits are air conditioning operation. So here you got the compressor, expansion valve, evaporator, heat exchange pipe, and also the two fan. So this is the construction of the reverse circuits air conditioner, compressor here. This is the condenser coil, reject the heat, expansion valve. So this is evaporator coil, absorb the heat. Absorb the heat and then compress and then reject the heat. So this is the air conditioner. The expansion valve is a cool refrigerant. So this is the ways we can use it. In this case, we can also see the cooling cycle. The compressor burn the compressed vapor refrigerant gas. This raise refrigerants are pressure and the temperature. Heat exchanging condenser coil is a dissipate the heat, and the liquid refrigerant flow into the expansion bar. The high temperature zone to low temperature zone is expand to the vapor. The vapor absorbs the heat, making the evaporated coil cool. The fan blow the evaporated coil and cool air in the room. So this is the ways of air conditioner cooling system, the construction of the rubber circuit air conditioner. The heating circuit is a rubber circuit air conditioner has an additional component that allows the fluid and refrigerant to these rubbers. The evaporator coil becomes an outdoor coil absorbing the airflow provided from the outside air. The heated vapor is compressed and further heated at the high temperature as it passes through the compressor, passes into the condenser coil, which is now in the indoor coil. The indoor fan draws and blows the air over hot condenser coil before returning the heated air into the room. So this is the way. So another thing is a two-phase stove connection. Electric stove called a 220 volt to 200 volt. So this is the upright range. The connection is here. So line 1, L1 connected to line 1, L2 connected to line 2, and connected to the R. So this is the electric stove connection. So this is the electric connection, and also the here the heat base equipment main open element. Hot plate is a A1, A2. So this is the connector here. So this is the bridge resistance. So this is the connection of the thermostat. Thermostat is a 2-wire thermostat. This is for the line, and this is the neutral, and this is pilot connection, the pilot lamp, and this is the electric plate. So this is a thermostat connection. Which terminals are indication for the controls or thermostat? In this case, I is a red power supply transformer. The B is a white heating controls are relay. Y yellow cooling control, and G is a green for the fan relay control, and O is a orange cooling damper. B is a brown heating damper. B is a malfunctional light. B is a heat pump, and Z is a low voltage fan switch. So this is the component of the thermostat. Describe the effect of the change in the thermostat setting from the low to higher. So in this case, the energy regulator control the current flow, change the bimetallic strip. In this case, change in the operation of the thermostat. If you change the bimetallic strips of bending, it will change the operation of thermostat. Explain why it is necessary to supply the full voltage. In this case, full function of the operation to be attained. Explain why the supply was not required to be connected to test a thermostat because of the involved with the temperature. So, as it is necessary to bridge any saving device on the hot water service to give the hot water on temperature basis. So this is no. So, describe the effect of the change in the thermostat setting from low to high. So in this case, the energy regulator control the current flow, change the bimetallic strip bending, it changes the operation of the thermostat. So list of three primary savings of factor that must be considered before what begins on the hot water service. In this case, we have to concern about the heat, electrocution, and mechanical stress. Replacements must be inspected. Replacements element must be inspected for the physical appearance and the resistance. The minimum insulation resistance for the heated tie element is a 0.01 MO. Is follow the AS SSR 3218 addition cross at 8.3.6. The battery is made out of the 4 individual cells connected in series. Each cell has the open circuit terminal voltage 2 volt, internal 0.1870, and can supply a maximum current 500 ampere. Determine the open circuit terminal voltage of battery, maximum output current of battery. In this case, E total number of cells multiplied E cell voltage, so 4 minus 2 is 8 volt. I maximum output, I maximum of the cells, so this is we got the 500 ampere, milliampere. If battery is a 90% efficient and deliver the current of 12 ampere over a 6-hour period, calculate the current necessary to recharge the battery in 10 hours. So in this case, ampere hour, IMU hour, so the 12 minus 6, 72 ampere hour. Ampere hour input, ampere hour output by the percentage n, so 72 by 0.9, you got the 80 ampere hour. So the I is a area hour divided by the time, so you got the 8 ampere you got. Here is a plan where we can place a fire alarm. We can place it like this. So this is that we can put into the alleyway or near the bedroom. We can put into the we cannot put the loading in the kitchen. So this is the connection of the supply usually. So this connection is this is the connection of the circuit breaker dual element off-peak water heater system. This is the dual element off-peak water heater system. The connection, this connection show the dual element off-peak water heater system. So this is a connection of dual element off-peak water system, heater system. Okay, this is the ways we explain about the water heater, heat and the water system. Heat and water system we explain about. Then we also talking about the water heater operation. The water heater operation is a water heating device include the instantaneous water heater or the storage water heater. The classification depending on the usage and there's a target rating. So it's we include a continuous water heater or the control load or the restricted hour water heater. So instantaneous water heaters are the water heated on the demand and then not stored. It requires a high power input, designed to deliver the steam only on demand when hot water is required. So this is for the operation of the hot water heater system. So this is the construction. In this case, construction include the copper container, 0.8 liter capacity, use a diaphragm flow switch to automatically connect the supply. Element rating is 80 ampere hour phase. So this is the connection construction of the three-way heater hot water system. So this is hot water system. For the outlet, this is the heating coil. This is the cool water input, and this is the electrical supply. So this is also three-way water can be heater can be designed. So the disadvantage cannot efficiently supply more than one tank at a time, fit in small area of the whole unit. Small 50-liter storage are available to fit in the cupboard. They connected as an instantaneous quick recovery water heater. Storage water heater type consists of the inner water container. It includes a heat exchanger from the outer metal casing to reduce the heat dissipation losses. Coil type can be the elements are placed into the side of the inner tank towards the bottom of the tank. So it can control it by the thermostat. So this is for the controls diagram hot water input here. Large storage capacity heaters are used to supply the multiple point with the hot water, while the smaller types storage units may be installed as in the bath heater. So in this case, here is the solar water heater in the sun coming here. So sun energy can be absorbed in the heat exchanger, and also hot water to cold water to hot water heat can be exchanged. So the solar storage water heater is a diagram is here. So the storage water heater classification are the continuous water heater, controllers are off-peak and the restricted hour water heater. So the additional heating element boosts the element. So this is about the cold bathroom, kitchen, laundry, hot and cool, and then so the additional heating elements are boost the heating. So this is the storage water heater type. This is roof mounted displacement type water heater. Water is fed into the bottom of the low pressure heating tank to dissipate the hot water drawn from the top. The main disadvantage of this system is that they are inability to produce a high demand area. So this is a room mounted air water heater system. So in this case, this is a room mounted, and this is the bathroom, kitchen, laundry, water can be taken out. So the gravity feed system is lower in the tank, allow the hot water to flow to this level at the factory faster rate. Cool water is prevented from the entering tank by the solenoid and the heating circuit command. So that the protection is installed with the overflow tray heating tank are vented at the atmosphere and to prevent the pressure damage. So here we is a main pressure type. So this is no feed tank. Continue flow the water from the connected to the water maximum, and also the operating at the full major pressure or operating at the maximum medium pressure. Booster heating element is connected at the near the top of the cylinder, and rubber short control operation included. So this is the top thermostat. Top thermostat is the Judas element tank should be set at the 10 degrees centigrade lower than the bottom element. This is the bottom element, top element. So the setting is included. So this is the top element must be set at the 10 degrees centigrade lower than the bottom element. So here anode is an outlet, temperature, pressure, rally bar, and booster heating unit. And this is the base influence inlet and the insulated water thermostat are terminal. So they are components of the water heater. So those water heaters are connected to the water pipeline, water heater, rally pressure drain. They are connected like this. And also the rally pipe has to be utilized, and the multiple storage tanks are connected here. Intrinsic safety devices are the essential part of the system to operate safely. All the unvented storage water heater must be fitted with the intrinsic built-in safety device. They include the thermostat, overpressure reliever, now cells are resetting over the temperature cutoffs. Replacement has to follow. When replacing any safety device, only approved devices should be utilized. When the water pressure in the main is too high, a pressure reducing bar should be fitted by the plumber. Cold water expansion bar is fitted to the cold water inlet and set to drip continuously during the heating cycle. So this is what so the solar water heating system is the heating of water in a wine climate. They affected by the tree, shaded dust, frost, and the wind. So this room mounted water heater system is the components of the tank and the solar panel. So when you apply the thermosiphon principle, water heated in the collector flow the upper part of the storage tank is replaced by the cooler water from the bottom of the tank. So the extra structure timber is supporting the weight, and non-corrosive heat transfer liquid flow into the solar collector, then heating the exchanger. So the heat energy transfer from the water. In this case, we use the blessed chromism markers is utilized. So here is a construction of the solar water system, solar water bottom element, anode, steel, and heat absorbing panel, insulation. Now here is a split system. Split systems are construction. So in this case, this is for the expansion bar, receiver, compressor, water tank, and evaporator. They are component of the split system. So the components can be the storage tank at the ground level. Solar collector is connected at the top. The additional distance between the two units prevent the thermosiphon principle from the working. The motor carbon pumps are the circulate the cool water from the bottom of the tank to the solar collector panels on the roofs. So the where the air is heated and circulated each to the top of the tank. A thermostatic control on the pump motor prevents the water from being circulated until the water in the collector is hotter than the water in the tank. The booster heating element is fitted to all of the solar heating system when the insufficient solar energy is available. So that it can also be manually operated. Thermostat function turn on the supply, reset the system to solar operation. So the heat pump principle is another type, is smaller to the refrigeration and the air conditioning system. Current and transfer up to 3 times the energy used by the motor to drive the compressor. So it operates with or without sun, absorb the heat from the outside even at the night. So this is the ways that we calculated. So this is a heat pump operation. system. So here you have compressor, filter, driving, evaporator, expansion valve, vapor tank, insulation, and a condenser coil. So hot water outlet inlet system. This is the heat pipe we utilize like this. So in this case, this is the compressed system. It is a heat pump circuit. A compressor is used to compress a cool, low pressure refrigerant gas. This gas is passed through the condenser coil. Is a heat exchanger, or it passes through the heat from the gas to water in the tank. During this process, hot gas are condensed. The began as a high pressure liquids which then pass to the evaporator, where the pressure is regulated from the sun air. So in this case, evaporation point at 30 degrees centigrade. So that we also utilize a office water system to control load. Control load and the switch modes are requirements. Control load is a load that is restricted to the receiving the supply by the electricity distributor to certain hours of the day or the night. Office demand loads and is as office demands load and is as such are the usually are restricted to the receiving the supply until the demand on the system is low. So the office demand loads and as such are usually restricted to receiving the supply and the demand on the supply system is low. So load control devices are the plug. Those are control devices and the lighting load control system. Office customers are expected in the service in the installation room. The type of the device to be used for any particular job will be specified or supplied by the supply authority. So to be done with the current metering requirement. So the receiver requirement is 750 Hz to 1050 Hz. They are the supply frequency of the 50 Hz is over frequency relay is operated. The connections of receiver are the wire in the series and the installed downstream of the kilowatt hour meter. So that the measure the control load. So the operation is contact open when the no triggering are signal. When the closed, when the trigger signal receive control contact will be closed, so that no current flow to the load. So the contractors to determining there's a load control and also time cloud is a control switch. So at this place we are talking about the water heater system. Also we're talking about the turret system. So the electronic metering is we utilize electronic metering. So there will be it measure the energy use. It measures the maximum demand, power factor, active power, and reactive power. So the first turret, second turret, and specification, they are included. And the current meter device is 100 ampere is element 1, 25 ampere is element 2. So this is for the hot water, so how the current will flowing. We also include as a programmable operation. How our operation, the turret 1 is 10 p.m. to 7 a.m. Turret 2 is should be the energy demand time restricted period generally not exceeding 74 hours in any period of the 24 hours. So this is the rule to the supply. Also that we also include the offload control devices, the water storage capacity of the element power rating and specific operations arrangement. They are affecting the offload control devices. A common domestic storage unit for the continuous turret supply is a 4x8 kilowatt, 80 liter heater. Having a recovery rate of 70 liter per hour for the 40 degrees centigrade. Continuous rates are required. No special turrets as usual. Power rating are such that a space of finance such circuit is necessary. So this is the connection of the Robert Shaw thermostat connection. The Robert Shaw thermostat connection is here. This is what the controllers are connection. That's a fixed thermostat connection. So also this is the Robert Shaw top element, how the top element connected, and also the controller. So this connection will be the based on the those information rubber short thermostat, bottom element, top element, we can draw it as a circuit. This circuit is a connection of the rubber short thermostat, top and the bottom element. So this is the connection of the rubber short thermostat and top and bottom element connection. So today's electrical trade 2, I have explained you about the water heater and the operation of the water heater, and also the control of the different water heater system and the direct system we are explaining. So this is what the trade 2 is completed for today, and also the electrical workshop for trade 1, workshop practice 3. So this is for the planning of the material. So safety in the workshop. So in this case, we have to observe the WHS 2011. Rule to be controlled. You are the ultimately responsible for your own safety. Make sure yourself aware of your surroundings. Identify any hazard or ask someone with the more experience. Think before doing anything. The events appear because of the it can happen the dangers. Individuals are unsafe practice. In this case, using the tool incorrectly. You have to if you use the tools incorrectly, it will be unsafe. Taking the shortcut, you have to follow the proper procedure. By following the shortcut, it will also causing the damage and the unsafe. Walking carelessly and being distracted and fooling about. Poor design of the equipment or the work environments are the unguarded machinery and the lack of the lights. Poor management of the organization. In this case, lack of the training and the use of the equipment, lack of the safety training, and NOSA enforcing the wearing the personal protective equipment. Those are the dangers to the workplace safety. So the workshop rule for the personal safety. Stay alert. Watch out for the things that are or the could become the hazards. You need to find out the fact is equipment. You have to know the methods or the treatment for the electric shock and report the all accidents, and do not wear the loose clothing which can catch the machinery. Do not wear the ring or the metal watch. So this is important because it can conduct the electricity. We are the rubber shoe, rubber shoe, and with the leather uppers, and also the steel toe socket your shoe must include a steel toe socket. To working with the heavy equipment, cover your hair with a cap. Always wear the safety glasses or the shield when using any power tool. When you are using any power tool, you need to wear the glass. Workshop safety rules are: keep the floor area clear of the obstruction and clean up any spray out or the grease. Watch your step. Don't fool around the workshop. Watch for the falling objects around the overhead crane. Be aware of the people walking overhead. Use a ladder safely. So those are important for the workshop safety. It means there's safety harness and glass before using and replace if damaged. Don't use any machine unless you finally understand in all aspects, especially safety aspects. Use your leg, not your back to lift. To safety. Don't use the damage or the wound to repair or the replace them. Make sure that the file or the two handles are securely fixed and not split and damaged in any way. Don't rely on the two-handle insulation for the protection from the electric shock. Always ensure that the work is firmly secured before using blade, spanner, screwdriver, go chaser, hacksaw, etc. Don't strike the hardened tools together, they may shatter. Don't try to stop the rotating machine by hand. Don't leave the machine running unattended. Don't leave the child key in the drilling machine. Don't run with the machine safeties are guarded remote. Don't use the grinder with the chow wheel with the excessive gap between the wheel and the wall to be set. Stand on the one side while starting the grinder for the first time after wheel has been replaced. Non-electrical hazard in the workshop. Fall from the height and the slippery surface. So electrical hazards are the equipment can fall from the height or the slippery surface can also be causing the injury. The mobile cover plate near the energizer equipment, confined space, lack of the sufficient light to work safely, excessive fatigue on workers, obstacles to the getting the equipment straight off, and also using the gas flame near the exposed electric conductor, using the conductor or the primary cleaning solvent, and temperature rise as a result of the combustion and the current working the condition, including cable, trolley, and explosive atmosphere. And use of the conductive tool and the equipment also important aspect. Electric tool equipment you have to prioritely utilize, and also personal effect usually was need to be aware of, should not be worn, and general was activity, welding, cutting, bracing, you also be follow the proper procedure. And also static electricity from the machine and clothing is also important aspect. Hot metals surface due to the grinding, welding, evacuation, excavation tool, also the models are metal from the arcs and the aceto material, swivel, you also be aware of. And don't use the grinder with the chow wheel with the excessive gap. So those are the important aspects for the general workshop safety. So now I have to explain you about the Bachelor of Applied Engineering, district study, and also electrical trade 2, also electrical trade 1. Electrical trade 1A, we got the workshop safety. Then we are talking about the diploma. First, we go to the electrical diploma 2022. Okay, so, electrical diploma 2022 got this system. So in this case, you can do the advanced diploma electrical engineering program. So after you have done a year 1 electrical trade study, in which introductory advanced diploma degree subjects are given, you can continue the full content of the advanced diploma electrical engineering. So this is for the unit link. Unit link given this link here, you see the link here. The code numbers are you can see on this link. So UE011, no? So those are unique group. You can start at any unique group, and this is the exercise and appropriate page number. So those unique groups that you can follow. So in this case, you have to do this study option 3. Firstly, you have to read. Here you can see the E1, 1, 1, 2, 1, 3, etc. Those numbers are from follow the study option 3. Study option 3 include the lesson video. So that you can read the video. Those are the video given. You need to read the video. For example, you see that E101, E1 for DC circuit, you view this as no video. After this, no, study option 2. Study option 2, or there you can study option 2. You have to read the lesson notes. So the study option 3 and lesson and view the video. For example, E104. E104 is given DC circuit, so you can view the those video fast. After that, go to the study option 1. Study option 1, click here, and here you can see the lesson notes. From here you can find out the lesson note, download the lesson note. Appropriate are E101, E104 are lesson note, E105 is a DC circuit. So you can read this E101, E104 here you can see. So those lesson notes you can download. So you can read as a lesson note. After that, here you can see the audio lesson. This is audio lesson. The audio lesson. So this is audio lessons are code number. This code number, from the code number, you can pick up the appropriate audio lesson. Then you can listen and unzip the file, and you can listen to the audio. So this is for the lesson aspect. And then you also have to do the textbook. So textbooks you can see here textbook. Textbook. Click this one, and you can download DC circuit. You can download a textbook. So every code number you can follow the same way. Firstly, you have to view the video, and then you have to download the appropriate written notes, and also you can also listen to the supporting audio file, and after that you can download the textbook. So this is the way you have to study. So this is a study program for the advanced diploma level. So the firstly this is the ways that you can study the advanced diploma electrical engineering. Now together with the electrical trades principle, I am introducing some of the advanced diploma aspect. So last week we have already explained you about the E029 to the electrical fundamental. This week we can also continue to providing the E029 electrical fundamentals video. So last week we already talking about the E029 electrical fundamental video. Lesson 2 has been completed, and now today's are lesson 3. Induction motor starting.
Okay, this program, 22 kilowatt, 450 volt, full load current is a 38 ampere 3-phase induction motor. So loud rotor current is a 75% of the full load current. Loud rotor torque is a 155% of the full load torque. Let me determine the starting current and starting torque for the start data connection. B is the primary resistor starting. C is the auto transformer starting at the 55% stepping. Firstly, we calculate start data connection. So in this case, starting current IST is equal to 300 by 3. So this is the 200% of the IFS. Starting torque, so this is the 155 by 3. So because of the IST or the start data is a QS starting current by 3. So DOS starting current is 300%, so 303, so 200%. And start data starting torque is a direct online starting torque divided by 3. Direct online 155, so 1.5 by 3, so 1.57%. Okay, now we use a primary resistance starter. So primary resistance starter starting current is 330% of the full load current, and starting torque is 300% of the full load torque. For the auto transformer starter, so starting torque is a 3% voltage by 100 square, and starting torque of the direct online starter. So in this case, we use a 55 bar at debit, 55 by 100 square. And so starting top 155. So 155 into DFN. So by solving this one, 46.9% in DFN. So this is the problem. So based on the load theory, you have to do this follow study. Topic 3, induction motor study. Study the slide 1 to 10. Do the exercises, question 18 to question 24. Topic 4, induction and synchronous motor. Study the slide 1 to 9. Do the exercises, question 25 to question 29.
Now we're talking about the density of friction.
So material science understands density, friction, and the linear motion. Density can be calculated by the formula mass divided by volume. Mass unit is a kilogram, volume is a meter cube. Relative density is the density of the material divided by density of the water. Specific volume is the volume divided by mass. So this is the equation to calculate the density. Okay, we saw this problem. A 300 milliliter of the sulfuric acid has a mass of the 1.11 kilograms. What is the density and relative density? So firstly, we calculate the density. Density is a mass by volume, 1.11 by 0.6. So this is the 1.85 kilogram per liter. So 1.85 kilogram per liter, you want to change to the kilogram per meter square, multiply with 1,000. So this is the 1850 kilogram per meter cube. So relative density, so the density of the sulfuric acid is 1850, and density of the water is 1,000 kilogram per meter cube. So we have to find the relative density. So density of the material divided by density of water. So the 1850 divided by 1,000, you got the 1.85. So based on the both densities formula and the example, you have to study the follow study. Topic 5, density, friction, and the linear motion. Study the slide 1 to 3. Do the exercises question 30 to question 32. The next topic is friction. Friction means that this is a mass. This object is lying on the surface. So this is the total weight. It's put on the surface, and surface got the opposite weight. So FW and Fn. Fn is the force on the surface to carry the object. So F is an external force. Ft is a tangential force. Tangential force caused by the friction between the object and surface. So that this U is between the object and surface. This is the coefficient of static friction, can be calculated by Ft divided by Fn. So therefore the Fp or Ft is equal to U multiply Fn. So this is what the friction equation. Okay, this problem, 100 kilogram mass and here is plate. So this is we tie with the rope. So 100 kilogram block is a rest on the plate. The coefficient of friction between the all surfaces. So this is 100 kilogram to this plate to this surface. So there are two surfaces. So two plates has a coefficient of friction. The coefficient of friction between the all surfaces is 0.2. So we have to determine the force required to pull the plate. Okay, firstly we calculate the Fn. Fn is equal to Fw. The formula is N multiplying G. Mass multiplying gravity. So mine is 100 kilogram. Gravity is 9.81, so you call it 981 Newton. Ft is equal to U multiplying Fn. So then U is a 0.9, Fn is a 981, so 196.2 Newton. So this is the only one surface. So this plate is facing the two surface. So this is the surface between 100 kilogram plate. This is the surface between plate and the surface. Surface between plate and the surface. So this is for the two plates. So for the two surfaces, you have to multiply with 2. So Ft is equal to 2 into Ft. 2 multiplied 196.2, so that's 392.4 meters. So that based on this, those are example in the theory. You study topics 5, density, friction, linear motion. Study the slide 1 to 9. Do the exercise at question 33 to question 35.
And linear motion.
So now topic is a linear motion. So this is the equation for the linear motion. S is equal to T multiplied V average. In this case, T is a time, S is a displacement, V average is average velocity. So average velocity, initial velocity V0 plus our final velocity V divided by 2. V is equal to V0 plus AT. So V is the final velocity, V0 is the initial velocity, A is the acceleration, T is the time. S is a V0 T plus half AT squared. So S is the displacement, V0 initial velocity, T is the time, A is the acceleration, and also V square is equal to V0 square plus a 2AS. So V is final velocity, V0 initial velocity, A is the acceleration, S is the displacement. So this is the equation to calculate the linear motion. Okay, we solved this problem. Find the total emergency stopping distance of a car and the total time taken from the point where the driver sight the danger if the driver's reaction time before applying the brake is a 0.9 seconds and the initial velocity is 60 km/h and the retardation due to the brake is a 7.5 m/s square. So this is the car. When the car is driving, so driver saw there's something wrong, so that he has to apply the brake. So this is the time before applying the brake. This is the initial displacement S1. So S1 the vehicle continues to move at the constant velocity. After that, he applied the brake, so the retardation, so negative acceleration 7.5 m/s square. So car slower and finally stopping. So therefore, we have to calculate the initial velocity. Velocity given as 60 km/h. So this is the kilometer converted to meter multiplied with 1,000. 1 hour got the 3,600 seconds. So divided by 3600. So therefore, the 16.67 m/s. So the time taken for this driver to apply the brake is 0.9 seconds. So for the 0.9 seconds, car is moving at the 16.67 m/s. So the initial displacement S1 can be calculated, V multiplied T. So the 16.67 velocity, time is 0.9, so we call it 15 meters. Okay, after that, the car is he apply the brake, car going to stop. So final velocity V0 is 0, initial velocity is 16.67 m/s. So the V0 square is equal to V square plus 2AS. 0 is equal to 16.67 square plus 2. Retardation is 7.5 m/s square, and then S2. So S2 is 18/5. So total distance between the S1 plus S2, so the S is equal to S1 plus S2. So 15 plus 18/5 equal to 33.5 meters. So another problem. A car starts from the rest at the rate of the 1/2 m/s square for 15 seconds. Determine the velocity reached after the 15 seconds. So the final velocity V is equal to initial velocity V0 plus 80. So V0 is 0, A is 1/2, and T is 15, so 18 m/s. Okay, so based on those linear motions, example and theory, you have to study. So topic 5, density, friction, linear motion. Study the slide 10 to 12, do the exercise question 36. The next topic will be the work and power. Mechanical work is equal to force multiplied distance. So W is equal to F into S. This is for the linear movement. For the angular movement, W is equal to T multiplied theta. T is a top, theta is angular displacement. So the angle multiplied 2 pi. So this is the angular displacement. Power is equal to work divided by time. Okay, this problem. A flywheel mass makes 200 revolutions. Torque is 35 Nm/meter. Find the work. So the W is equal to T into theta. So T is 35, theta. So this is 200 revolution. 200 multiplied 2 pi. So this is the multiplied 35 multiplied 200 multiplied 2 pi. So you got the 44000 joules. Another problem. 4 is 15 Newton. Distance 3 meter. Find the work. So the W is equal to F into S. The 450 Newton, distance 3 meter. 50 multiplied 3, so you got the 150 joules.
And force by acceleration.
So force plus and acceleration. So for the vertical motion, V is equal to V0 plus GT. The G is 9.81 gravity. V square is equal to V0 square plus 2GH. A is V0 T plus half GE square. So 4 is equal to M multiply A. In this case, 4 is equal to mass multiply acceleration. So we have to calculate this problem. Determine the acceleration of a body of the 25 kilogram mass due to entirely to its own weight. So firstly, we have to calculate the weight. F is equal to M into G. So the mass is at 25, G is at 9.81. So you got this at 245.3 meter. So acceleration A, the formula is at 4 divided by mass. 4 is at 245.3, mass is at 25. So you got the 9.81 meter per second square. So this problem, the mass is lying on the 35 degrees inclined plane. So we have to determine the acceleration. So that this mass, so the horizontal force can be calculated mg sine theta. So that 4 is equal to mg sine theta. Another equation is that 4 is equal to mass multiplied acceleration. Therefore, the mg sine theta equal to m into a. So that m and m will be cancelled. So that a is equal to g sine theta. So 9.81 multiplied sin 35, you got the 5.63 meter per second square.
The next one is acceleration against the resistance.
So acceleration against the resistance, so that the mass m is moving at the FD, so the FD is a resistance. So the acceleration can be calculated net force divided by mass. So FD minus FD divided by m. So this is the when the object is moving against the resistance, we have to calculate this formula. A is equal to FD minus FD by m. So we solve this problem. A train of the total mass of 120 ton is traveling at 60 kilometer per hour on a level track. The traction resistance is 80 Newton per ton. Calculate the traction effort required to accelerate the train to 100 km per hour in 30 seconds. So the initial velocity is 60 km per hour. So 60 km per hour, so 60 into 10 power 3 per hour is divided by 3,600. So you got a 16.67 meter per second. And the final velocity began at 100 km per hour. So the 100 kilometers change to meter is multiplied with 10 power 3 per hour is divided by 3,600. So 27.78 meter per second. So that we want to calculate the acceleration. So then use the formula P equal to V0 plus AT. So the final velocity V is at 27.78, initial velocity V0 is at 60.67, A and we in 30 seconds, so T is at 30. So by solving this one, A is equal to 0.37 meter per second square. So we can calculate. So this is the use of this formula. F is equal to FB minus FT. So then F is equal to MA minus FB minus FT. So the mass is 120 ton. 120 divided to the kilogram. So multiply it by 3. A is 0.37. FB minus 30 F4. 30 F4 is every 1 ton equal to 80 Newton. So 80 Newton per ton. So they are total 120 tons. So this is 80 multiplied 120. So by solving this sort of FB, we can get 54,000 Newton or 54 kilonewton. So this is the way we can calculate the FB. Now is this problem here. This is the two pulley A and pulley B. A equal to 5 kilogram, B equal to 2 kilogram. We have to find the acceleration of body AB on the force, tension, and the cord. So in this case, when you draw the A, so this is the A is the acceleration is going downward, and one is outward. So the force can be calculated mass multiplying gravity. So the mass is 5, gravity is 9.81. So you call it 49.05 Newton. And for the P, so this is for the downward is a force equal to mass multiplying gravity. So minus 2, gravity is 9.81, so 19.62 Newton. So then this acceleration is going downward. So there are two forces. The two tensions are two forces. F1. Here is a 4B is only F1 and the acceleration B. So the acceleration is the half of the acceleration B. So those are the in the problem information. So first is we calculate for this body B. Force multiply mass multiply acceleration. So 4 is equal to, so this is the F1 minus FB is equal to M multiply AB. So F1 minus FB is 91.62 minus 2 AB. So this is equation 1. And for this A, so formula is FA minus 2F1 is equal to MA into AA. So FA is 49.05 minus 2F1 minus 5AA here. So A is AB by 2, so we substitute. So the 49.05 minus 2F1 is equal to 2.5A0. Here F1, here is 2F1. So equation 1 multiplied with 2. 2F1 minus 39.24 is 4AB. So 49.05 minus 2F1 is 2.5AB. So by solving this one, finally you got the AB 1.51 meter per second square. So AA can be calculated half AB. So that's 0.755 meter per second square. So F1 is equal to 2AB plus 90.61. So you substitute the AB value, you got that 22.6 meter per Newton.
Torque, work, and energy.
So you have to do this further study. Topic 6 force, mass, and acceleration. Study slide 1 to slide 8. Do the exercises, question 37 to question 40. So another topic with the torque, work, power, and energy. Torque is equal to I multiplied alpha. In this case, this is a torque, Newton meter, I is a moment of inertia, kilogram meter square, alpha is the angular acceleration, radian per second square. So we solved this problem. Determine the net torque required to give the flywheel with a moment of inertia 0.75 kilogram meter square and angular acceleration 16 radian per second square. So you write the equation T equal to I multiplied alpha. So I is a 0.75 and alpha is 16. So we calculate, so this is 12 Newton meter. Another problem, determine the torque required to accelerate a turbine rotor undergoing a time balancing test from rest to the 15,000 RPM, speed in the 80 seconds. In the mass moment of inertia is 11.5 kilogram per meter square. So firstly, you have to calculate the omega. Omega is the angular velocity. The formula is 2 by RPM by 60. So 2 multiplied 3 by 1416 multiplied 15,000 divided by 60 to 1751 radian per second. So the omega equal to omega 0 plus alpha t. So the final omega is 1751, omega 0 is 0, alpha time is 80 seconds. So from here you got the alpha 19.63 radian per second square. So torque equal to moment of inertia multiplied angular acceleration. So the 11.5 multiplied 19.63, so you got a 22.58 Newton meter. So this is the calculation of the force and the moment of torque and the moment of inertia. Another topic with the centrifugal force. Centrifugal force F is equal to mv squared by r, or mr omega squared. M is the mass, I is the radius, or the moment, V is the velocity. Omega is the angular velocity. So we have to solve this problem. Determine the centrifugal force adding all the passenger or the mass 75 kilogram in the car traveling at the 90 kilometer per hour around a curve of the 100 meter radius. So that in this case, our mass is 75 kilogram. Substitute. You have to use the formula S is equal to mv squared by r. So mass is 75 and 90 kilometer per hour. 90 multiplied 10 power 3 change to the meter per hour is divided by 3600 seconds. So the 90 into 10 power 3 by 3600 square. And curve or the radius r is 100. So you substitute this formula, you got the 468.75 Newton. So power can be calculated torque multiplied W. Torque and W is angular velocity. Power equal to force multiplied velocity. So this is the way we calculate the power. Okay, this problem. A train moving at a 63 km per hour requires 40 kN of kinetic effort. Determine the driving power. So the velocity is 63 km per hour. 63 change to the meter multiplied with 1000. So 1 hour got the 3600 seconds. So you got the 17.5 meter per second. So power is equal to force multiplied velocity. Force is 40 kN, velocity 70.5 meter per second. So by calculation that's 700 kilowatt. So the potential energy is mgh. So m is a mass, G is the gravity, A is the height, Ke is the half mv square, M is the mass, B is the velocity, or Ke is the I omega square by 2. So here is the I is the inertia, omega is the angular, the velocity by 2. Okay, this problem. Calculate the kinetic energy of a flywheel at the inertia 61 kilogram per meter square, rotating at the 250 rate RPM. So we calculate KE is I omega square by 2. So I is 61, omega 2 by 250 divided by 60 divided by 2. So you got the 2090 kilojoule. So based on those are exercises, you have to study topic 7, torque, work, power and energy. Study the slide 1 to 13. Do the exercises, question 42 to question 55.
And momentum and impulse.
Okay, this topic is a momentum and impulse. So momentum is formula is A multiplied V, A is the mass, V is the velocity, impulse is a FD is to MV minus MV0. So this program, a block of the wood of the mass 2 kg is freely suspended on the string. A balance of mass of 75 gram is fired horizontally into the block. If the velocity before is 415 meter per second, calculate the velocity of the block. So that before this wood and the balance are not hitting, so the M1 V1 plus M2 V2. After hitting together, M1 plus M2 and the common velocity V. So the M1 is the mass of the balance, V1 is the initial velocity of the balance. M2 is the mass of the block, V2 is the initial velocity of the block. So the mass of the balance is 75 grams, so change to the kilogram divided by 10 power 3. Initial velocity V1 is 415. The mass of the block is 2 kilogram, initial velocity is 0. Then you have to add the M1 and M2 and final velocity V. So by solving this one, final velocity V is 15 meter per second. Another problem, when a ball of 50 grams is struck by a club, they are in contact for a 0.001 second. After the impact, the travel at the 45 meter per second, find the force. So the force, in this case, this is FD is equal to MV minus MV0. So the force multiplied, they are stuck together, 0.001 second. So this is the 50s gram ball, so 50 divided by 1000, initial velocity 45. The flight is 0, so and mass and velocity are 0. So then we calculate, so that from here, F is 6,000 Newton.
Impulse momentum, another video.
Based on those impulse theory and the example, you state the topic impulse, state the slide 1 to 3, and do the exercise question 56 and question 57.
And law of the machine.
Okay, now topic is the law of the machine. So mechanical advantage can be calculated load divided by F4. So the M is equal to FA by FF. Velocity ratio is the distance moved by the F4 divided by distance moved by the load. So VI is equal to SF divided by SS. So this problem, a simple machine in the figure, the load is a 450 Newton. So this is the load. F4 is a 50 Newton. The load at F4 moment is a 100 millimeter and 1200 millimeter respectively. We have to calculate the mechanical advantage and velocity ratio. So mechanical advantage formula is load divided by F4, so FA by FF. So the load is 450, F4 is 50. So the 450 divided by 50 equals 9. Velocity ratio, so this is the distance moved by the F4. So distance moved by the F4 is 1200, and distance moved by the load is 100. So the SF by SA is a VR, so the 1200 divided by 100, you got the 20. So what an efficiency? N is equal to mechanical advantage by velocity ratio. The law of the machine. So every machine which can be represented by this equation. This is a linear machine. FE is equal to AFL plus B. So FE is a F4, FA is a load, A is a slope of the graph, B is a particle cutting point. So that we can plot this graph here. Load FA is a 0, 200, 400, 300, 800, and 1000. F4 FA is a 5, 25, 45, 65, 85, and 105. So we can plot the graph. So A in this case, a horizontal FS here, vertical FS. So the vertical starting point is here 5, and then this slope. Slope is divided by 25 by 200. You call it slope. So this slope we draw. So we can draw it this graph. So this is for the law of the machine. So based on the load theory, you study the topic 9, the law of the machine, study the slide 1 to 8, do the exercises, question 61 to question 63. Another topic is the mechanical drive system. For the mechanical drive system, power can be calculated omega multiplied T. Omega is angular velocity, so 2 by mi60 into d watt. This is a torque and it's an RPM. So this is a lever. So this is FE, this is DE. This is FN, this is DN. So velocity ratio can be calculated DE by DN. And also this is AC. So this FE is here and this is DE. So this is the diameter of this FE radius. And here is the FA. This is the load and DA. So this is the diameter of the load circle. So FE is a F4 and DE is the diameter of the F4 circle. And FA is a load. DA is the diameter of the load circle. So in this case, velocity ratio can be calculated DE by DN. Okay, based on this theory, you have to do this whole study. Topic 10 mechanical drive system. Study the slide 1 and 2. Do the exercises. Questions are 64.
And finally, we can talk about the strength and strain.
So this is the strength of material. So determine the weight of the tubular steel column, 120 millimeter outside diameter, 120 millimeter inside diameter, and 3 meter high. So the cross-sectional area you can calculate pi by 4, outside diameter square minus inside diameter square. So this is 3 by 4 by Newton power minus 3 meter square. So following the cross-sectional area into line, length to the 3 by 4 by Newton power minus 3 area, and the height is 3 meter. So 0.0104 meter cube. Weight density multiplied volume multiplied G. So volume density is 80.86 for the mi-steel. Volume is 0.0104 meter cube G 9.81. So you call it 793.3 Newton. Ultimate strength is maximum of 10 by 4 divided by cross-sectional area. Is steel specimen 10 millimeter diameter, structure under the 37 kilonewton. Find the ultimate strength. So ultimate strength UDS is force by A. So this is the force is 37 kilonewton. Divided 37 Newton over 3. Area is pi by 4 into d square. So d square means 10 millimeter. So the 471 Newton per meter millimeter square. So this is what is our strength. Shear strength means that this is the perpendicular force. So this perpendicular force are punched at this metal. So the shear strength can be calculated. Force by pi dn. Pi multiplied this diameter as a thickness. So strain is the deformation. When the force applied, this power will elongate. So elongation is a delta L, original length is L. So delta L by A is a strain. And also the deformation, this is the H deform, original length L. So this is H by L. Shear modular can be calculated straight divided by strain. Strain is F by A, strain is delta L by L. So this is for this problem. The force is applied. Force is 11 by 3 kilonewton. So this is this pin. This pin is a diameter is 10 millimeter. We have to find the two shear strength. So that this pin suffer the 2 force. So that this is the area is a 2 area. This side area, they suffer the force. So that 2 multiplied by d square by 4. So diameter is 10 millimeter. So by calculation that 157 millimeter square. So the strength is going to force by the area. So force is 11 by 3 kilonewton, area is 157, so 72 into 10 over 6 Newton per millimeter square. So the factor of safety can be calculated, ultimate strength divided by working strength. So based on this theory, you have to do the topic strength, study the slide 1 to 7, do the exercises, question 69 to question 72.
Okay, all the things we can study from this side here. Video lesson. highlightcomputer.com/. Video lesson. And you can see the slide 51 to 59. So those are the lessons regarding the E029. material science, and electrotechnical problems. So those things are written notes. Written notes for those video you can get from here. If you don't highlight computer.com/video lesson.pdf, and then you see the PP1 to PP9. Do not click the 5.3 link. So you click this link, and from the page PP1 to PP7, those are the written notes for those are video lesson. Video lesson for electrotechnical problem and material science.